So in this lesson, I'm going to talk about polar versus Cartesian coordinates. So if we draw, let's say, let's start with the following. Let's take a point here. Let's say we move along the x-axis. Let's move 4 units along the x-axis, and then we move by 3 units along the y-axis, so we have the following point. So how can we write down the coordinates of this point? Usually, let's call this point P. What we can say is that P, the coordinates of P are what? Let's say 4, 3. So that's quite straightforward. That's probably what you're used to in most of your studies. But is there any other way we can use to characterize the position of P? Instead of looking at how much it is displaced or moved along the x-axis and along the y-axis, what if we take this distance? Let's call it R. And do we need anything else to characterize this point? I'm also taking this angle here. So as you can see, if I use R, so the distance, and the angle, which you may call theta, what we can say is that P is positioned at a distance R from the origin and at an angle which is theta. Here we are expressing P in Cartesian coordinates, whereas here we are expressing P in polar coordinates. How do we convert from Cartesian coordinates to polar coordinates? Let's see. Let's say we have the following point. We want to find R and theta. So to find R, as you can see here, I will draw again that we have our point is moved, let's say, by 4 units along the x-axis and by 3 units along the y-axis. As you can see, R corresponds to the hypotenuse of a right triangle. So that means we can calculate R by using Pythagoras. So we can say that R squared is equal to 4 squared plus 3 squared, which is equal to 16 plus 9. So we have, if we take the square root, we get that R is equal to 5. So now we got the value of R. How can we get the value of theta? So there are different ways of doing it, but the most straightforward, theta will be this angle here. So what we can take is, let's say, tangent of theta will be equal to 3/4. That means that theta will be equal to tangent to the minus 1, the inverse function of 3 times the minus 1 of 3 over 4, which is equal to 36.9. Okay, so now we have both r, which is 5, and theta, which is 36.9. As you can see, we can either express our point in Cartesian coordinates, so we have a coordinate 4 and 3 along the x and y axis, or if you want to express it in polar coordinates, we get 5 and then 36.9, which is the angle. Alright, so by the way, this tangent to the minus 1, you will find it written also as follows. This arc tangent. So that's the inverse function. If you apply that to a specific tangent, it gives you the angle. Alright guys, that's it for this lesson, and I hope everything is clear. If you have any comment, you can just leave a comment below.